All right, so now that we know how to do the empirical formula, the next step is to determine how to do the molecular formula. In order to do that, we need to understand what our number of empirical formula units are. And the way we're going to do that is we're going to divide the molar mass of the molecule by the molar mass of the empirical formula. Okay? So, for instance, right here, if I've got this problem, the empirical formula molar mass of a substance were determined to be C2H4O and 132.16 grams or 16 grams per mole respectively, determine the molecular formula. Okay, so I know that the molar mass of let's see here, how do I know the molar mass of the empirical formula? Okay, because I can figure out the molar mass of the empirical because this is the empirical formula, so you just determine what the empirical formula is. Okay, so we do the math and we see it's 44.06. Okay, the problem tells us that the molar mass of the compound is 132.16. So I divide that number by this number, and I end up getting 3 for my number of empirical formula units. So then what I do is I multiply all of these numbers by 3 to get my, my molecular formula. Okay, and that's how you do it. So let's take a look at example 9-38. The empirical formula of a carbohydrate is CH2O, and its molecular mass is known to be 240 grams per mole. What is the molecular formula for the carbohydrate? Pretty easy. My molecular mass for my entire molecule is 240. Okay. My molar mass for my empirical formula only is 12.01 for carbon plus 2.02 for hydrogen, because there's 2 of them, plus 16 for oxygen. I get 30.03. So I'm going to divide this by 30. Okay, so 240 divided by 30 is 8. So I have 8 empirical formula units. What do I do with my number of EFUs? I'm going to multiply them by all of my subscripts in my empirical formula. So therefore, my molecular formula is C8H16O8. And there we are. There we have it. Okay. Now this is going to be a little different for the kind of problem that you're going to see. Likely you're going to see a problem like example 9-39. So this problem tells us that the empirical formula for a hydrocarbon is known to contain 92.3 percent carbon, and its molecular mass is known to be 78 grams per mole. What's the molecular formula? Okay, now it doesn't give us a whole lot of information here. I know that it's a hydrocarbon, so therefore I know it contains carbon and hydrogen. Okay, so I'm going to write hydrogen up here. I know that it's 92.3% carbon, therefore the other part of the 100% has got to be 7.7% hydrogen. Okay, and so now in order to do this problem, I need to calculate my empirical formula by doing my empirical formula routine. Okay, so my first thing is percent to mass. Okay, in order to do percent to mass, I'm just going to change these percent signs to grams. Done. Okay, then I'm going to do mass to moles. Okay, so I'm going to go for hydrogen. I've got 7.7 grams divided by 1.01 equals 7.624 moles. Okay, carbon, I've got 92.3 grams divided by 12.01, and that is going to be 7.685. 7.685 moles. So now we've done percent to mass, mass to moles. So now we're going to divide by the smallest. So when we divide by the smallest, we're going to choose the one that's the smaller, and we're going to divide both by that. So we're going to do 7.624. We're going to divide this by 7.624. And we're going to get essentially 1 for both. Okay, this one's going to be exactly 1. The other one, 7.685 divided by 7.624. It's going to be like 1.008, so it might as well be 1 as well. So that tells us that our empirical formula is just CH. Okay, so what I need to do now is I need to find the molar mass of CH, which is 12.01 plus 1.01, which is 13.02. Okay, and we're going to divide 78 by 13.02 to get our number of empirical formula units. So I'm going to do 78 divided by 13.02. That's not right. 78 divided by 13.02. That's not right. 78 divided by 13.02. There it is. And I get 6. Okay, I get that I have 6 empirical formula units. So what I'm going to do with my number of empirical formula units is I'm going to multiply it by my subscripts, and so I end up with C6H6. So what that means is that this is my empirical formula, and this is my molecular formula. So if I ask you for the empirical formula on the test, you're going to give me this. If I ask you for the molecular formula, you're going to give me this. And that is how you do it.